Find the current through 1 ohm. Find the current through 1 ohm. What is the nature of circuit? Neither series nor parallel. Combination of both. So how to solve this? Solve yourself. Find the current through 1 ohm. We have to find the equivalent resistance first. Once you get the equivalent resistance, you can find overall total current. Once you get total current, you can find the current through 1 ohm. So find the equivalent resistance first. Find the equivalent resistance. Equivalent resistance. While finding equivalent resistance, where we have to start? Always, if you start at correct point, then only you will get. You can proceed. Always, you should start from the tail. Where this is single source circuit. That's why we can simplify this and we can solve. Suppose there are two sources, means we cannot apply. We cannot apply this. We have to apply some theorem or Kirchhoff's voltage law or nodal equation. You have to write and you have to find it. But here single source, that's why we can reduce into single equivalent resistance and we can find the current. This circuit consists of only one source. That's why we can find equivalent resistance and solve. Where to start equivalent resistance? We have to take the far away. This is source, means which is far away from source. This part is far away from the source. That's why these two are parallel or series. How to find whether it is parallel or series? Total current is coming here. Here the total current is coming here and is divided into two parts. Current is divided. It means what? Current is divided means what? Current divided means parallel. So we have to think like that. So total current is divided into two parts. That's why it is parallel. Therefore, 1 ohm and 2 ohm are in parallel. Find the equivalent resistance. Yes. What are you saying is correct. 5 volt, 3 ohm. The parallel combination of this is 1/2 plus 1/1 equal to, then for that answer, you have to find X inverse. You will get 0.67 ohm. The equivalent resistance is, now these two are in series. We found parallel combination of these two, that is equal to 0.67 ohm. So we put that. So this is equivalent to 3.67 ohm, 5 volt. Therefore, what is the total current? I equal to 5 divided by 3.67 equal to how much? 1.36 amperes. 1.36 here also 1.36 amperes. Therefore, current through 3 ohm is asked, means 1.36 amperes. But the current asked is in 1 ohm. That's why we have to go further. This circuit. Here, what is the current through this? 1.36 amperes. Here it is entering 1.36 amperes. We know one theorem. What is that? Current dividing theorem. So we have to find 1 ohm. Therefore, other branch resistance divided by sum of resistance. For parallel circuit, if you want to find current in the one branch, means we have to use the current dividing theorem. Therefore, I1. Why I am calling this I1? Current through this is I1. Current through this is I2. Current through total current is I or I3, you can call. I1 equal to what? Total current is how much? 1.36 multiplied by other branch resistance. What is that other branch? 2 ohm. Sum of these two resistances, 2 plus 1, 3. 0.906 amperes. I1 equal to 0.906. This is one way of solving. Suppose I am modifying this. I am modifying this circuit like this. Is it possible to solve this way? No, because two sources are there. Because two sources are there, either we can go for superposition theorem, or we can go for KVL or KCL. We can apply and we can solve. We cannot solve this in this way. By equivalent resistance method, we cannot solve. When we can solve equivalent resistance method, if only one source is there, we can solve. You understand this? Otherwise, we have to apply some theorem or KCL or KVL. We have to apply and find. We are not going to solve this sum. What are the other methods? By using that method, how to solve this sum? That we will see now. Now, we will apply the same sum. We are going to solve by another method. 5 volt, 3 ohm, 2 ohm, here 1 ohm. 1 ohm. So I want to solve by KVL, Kirchhoff's voltage law. For that, I want to assume currents. You can put any direction as you wish. You can put any direction, but we have to start from the source. We have to start from source. Any branch, but initially you start from source. Let us assume that current through this is I1. I am assuming current through this is I1. Let us assume that the total current I1 is divided into two parts. Let us assume that current through this is I2. Therefore, what is current through 2 ohm? I1 minus I2, because the total current, some part is going as I2, the remaining part is I1 minus I2. I1 minus I2. That's all. We have to check in this branch what is the current. In this branch, what is the current? Here, what is the current? Definitely I1. You have to check whether it is correct or not. What is current entering here? I1 minus I2. What is entering here? I2. If you add, you will get I1. You have to check. This is simple circuit. But in some complex circuit, you have to check. Some 3-4 branches are coming, means you have to add and check whether we are getting I1 or not. If you are getting I1, you marked correctly. Yes, we are getting I1. That's why what we marked is correct. It is simple sum. That is different. But anyhow, finally, you have to check finally whether you got I1 or not. To check whether we marked correctly or not. Now, I want to apply KVL, Kirchhoff's voltage law, to find current through 1 ohm. Because the question is, find current through 1 ohm. For that, I am going to use KVL, Kirchhoff's voltage law. Kirchhoff's voltage law says what? Algebraic sum of potential drop and EMF equal to 0. This is EMF. 5 volt is EMF. If you travel, I am going to travel like this: A, B, C, D. Like that, I am going to travel. First, I am going to travel from D to A along the current direction. Am I correct or not? Yeah, every branch you have to note the current direction. What we mentioned, this current direction need not be same. Actual current direction may be in the reverse direction. You need not bother. But you have to assume the direction is from D to A. We are traveling along the current direction. We are traveling along the current direction. So from D to A, we are traveling. You are traveling from 0 to 5 volt. Am I correct or not? This terminal is 0 volt, that terminal is 5 volt. Therefore, you are traveling from 0 to 5 volt. If you travel from D to A, you are traveling from 0 volt to 5 volt. There is a rise in potential. Am I correct or not? That's why plus 5. Why I am putting plus 5? While traveling from D to A, I am considering the loop D, A, B, C, D. I am considering the loop DA, BCD. I am starting from D. If I travel from D to A, there is a rise in potential, positive, increase in potential. That's why I put +5. You are traveling from A to B. What will happen? Current direction is from A to B. There will be a fall in potential. Am I correct or not? This 5 volt will be reduced because of resistance. There is a fall in potential. That's why minus. What is the drop across 3 ohm? 3I1. So why I am putting minus? Because fall in potential. That's why 3I1. I am traveling now B to C. I am traveling from B to C. What is the current direction? B to C. That's why again fall in potential. That's why again minus. Minus 2 times I1 minus I2. Any other resistance or source? Nothing. So equal to 0. That is KVL. I applied KVL. Simplify that circuit. If you simplify that, what you will get? 3 minus 3I1. Simplify. Minus 2I1 plus 2I2 plus 5 equal to 0. Or we can say that minus 5I1 plus 2I2 equal to minus 5. Or 5I1 minus 2I2 equal to plus 5. Let it be first equation. Am I correct or not? This is to understand. That's all. Review of your BW. Now we have to write the equation for second loop. In that second loop, I am marking this as E. This is F. So I am going to consider the loop CBEFC. Consider the loop CBEFC. First, where I have to start from C. I am traveling against current direction. I am traveling against current direction. What will happen? There will be a rise in potential or fall in potential? Rise in potential. That's why plus. Plus, sir, here you put minus, here you are putting plus means what way we are traveling. Suppose I am writing BCFEB. Suppose I am writing equation. Listen this, then you can write. Suppose I am writing equation for BCFEB means you are traveling along current direction. Put minus sign. That's all. Here, while coming to 1 ohm, here you are traveling against current direction, you will get plus. So, whatever the loop you are considering, accordingly you have to write. You will get correct sign. So, CBEFC. I am traveling from C to B. I am not considering this. I am not considering this. I am considering this loop CBEFC. CB, I am traveling against current direction. That's why plus 2 times I1 minus I2. 2 times I1 minus I2. Traveling B to E, no element. No problem. From E to F, you are traveling along current direction. E to F. In 1 ohm, you are traveling along current direction. That's why minus sign. Minus 1 times I1. 1 times I2. No element in FC. That's why equal to 0. That's all. Sorry. Equal to 0. No EMF. Only drop only. That's all. Now simplify this 2I1 minus 2I2 minus I2 equal to 0, or 2I1 minus 3I2 equal to 0. Let it be second equation. Solve these two equations for I2. Directly you will get answer. Ignore class test, that will reflect in the internal mark. That will reflect in the final result. So instead of concentrating on final examination, you concentrate on class test to get good marks, so that easily you can get 26, so that you can easily clear the subject. Okay, what is that answer? I2 equal to 0.909 amperes. So I2 is current through 1 ohm. I2 is current through 1 ohm. This way also we can find. This is called by using KVL, Kirchhoff's voltage law. Another method, loop current method. The same can be solved by using loop current method. 5 volt, 3 ohm, 2 ohm, 1 ohm. Loop current means this is called loop. Loop means closed path. Loop is nothing but closed path. This is one loop. This loop can be called as I1 loop. A closed path, any closed path is called loop. Loop 1. This is loop 2. That's why it can be current through loop 2 is I2. Now we have to write the equations. So how we can write? The same way we can write. For KVL, how you wrote? What is, you are traveling from A, B, C, D, A. For that, here raise in potential, plus 5. Then there is a fall in potential, plus 5, minus 3 I1. Here again, we are traveling along current direction. This direction is I1. This direction is I2. Therefore, I1 minus I2. And we are traveling along I1 direction. Therefore, I1 is positive. I2 is negative. I1 minus I2. Why I am considering while traveling from B to C, I1 minus I2? I1 is positive. That's why I1 minus I2. Why minus? We are traveling along current direction. Minus 2 times I1 minus I2 equal to 0. That's the same equation you will get. Another one is, for second loop, if you write EF, if you travel from B to F, no element, E to F, I2 is there, minus I2. Hey, don't talk. Minus I2, minus, here you are traveling around I2, therefore I2 minus I1. I2 minus I1, again we are traveling along current direction, that's why minus. Why minus? You are traveling along I2. Why I2 minus I1? Because now we are considering I2. I2 minus I1 equal to 0. So if you solve, you will get the same equation. The same KVL equation you will get this way also. Another way is that. Another way is that. That is called Maxwell's equation. R11, R12, R21, R22, I1, I2 equal to V1, V2. Here, R11 means the first loop. What are the elements in the first loop? R11 equal to 3 plus 2 equal to 5. 3 plus 2 equal to 5. Therefore, R11 equal to 5. What is R12? It should be common to both first loop and second loop. The suffix 12 you should consider. It should be common to both first loop and second loop. Which resistance is common to both the first loop and second loop? 2. Therefore, R12 equal to 2. But we have to consider the direction of currents. I1 and I2 are in opposite direction. That's why minus. The rule is like that. If both currents are same direction, plus. So minus 2. Then R21. R21 equal to what? Common to second loop and first loop. The same element you will get minus 2. Why? 2 ohm is common to second loop and first loop. What is R22? R22 equal to what? 1 plus 2, 3. 1 plus 2 equal to 3. Now write that matrix form. If you write in the matrix form, what you will get? 5 minus 2, minus 2, 3, I1, I2, and here V1. V1 is voltage EMF in the first loop. If it is in the direction of I1 plus, if it is in the direction of I1, sorry, what is the direction of I1? From D to A, there is a rise in potential. The direction of I1, rise in potential, that's why plus 5. Here no EMF, that's why 0. Hey, check whether you got the same equation. 5I1 minus 2I2 equal to 5. We got the same equation. Second equation you check. Second equation 2I1 minus 2I1 plus 3I2 equal to 0. Sign can be changed. So you got the same equation. Therefore, if you solve this for I2 equal to 0.909 amperes. We got. Do you understand this? Suppose I want I2. This is 2 by 2 matrix, no problem. Suppose 4 by 4 matrix, 3 by 3 matrix, 3 by 3 matrix, not 4 by 4, 3 by 3 matrix. How to find I2? Suppose I want to find I1 also. I want I1 also. I1 equal to what? I1 equal to determinant of this matrix. I1 means first column replaced by right hand side. 5, 0, minus 2, 3. Whole divided by A, that is 5 minus 2 minus 2, 3. That is I1. Determinant of this. What is I2? I2 equal to, in the same way, you have to replace the second column. Second column replace 5 minus 2, 5, 0 divided by same 5 minus 2 minus 2, 3. That's all. Find I2. Check whether you got the same. Find the determinant. Find the determinant of numerator and denominator. Find it. Check whether you got the same answer or not. Power. So here, power equal to the product of V and I. P equal to product of V into I. The unit is watts. Unit is watts. Watt. Suppose they are asking, what is the power dissipated in EF? Find power dissipated in EF. How to find power dissipated? The same question, you have to find power dissipated in 1 ohm. You have to find. What is current through that? 0.909 amperes. That's what we found, But we do not know V. If you know the drop across 3 ohm, we can find it. That is 1.36 multiplied by 3. If you subtract from 5, you will get the drop across 3 ohm. The remaining parallel, so both has same voltage. So we can find. That way also we can find. So V we have to find. Therefore, to find V, voltage across 3 ohm equal to what? 1.36. Am I correct? 1.36 multiplied by 3. How much? 4.08. So V3 equal to 4.08 means V2 equal to V1 equal to what? 5 minus 4.08. That is equal to how much? 0.992. Okay. 0.92 volt. Now we can find the power dissipated in 1 ohm. P equal to 0.92 multiplied by 0.909. So many watts. How much? 0.896 watts. 836 watts. But we not find V, because this VI by Ohm's law we can modify this. We want to write instead of V, we want to write in terms of I. V equal to what? IR. So V equal to IR multiplied by I equal to I square R. Already we know resistance. We know current. That way also we can find. Check whether you got the same answer. 0.909 whole square multiplied by resistance is 1 ohm. Almost same answer, because here different values. That's why. Because you are truncating some values, But anyhow, 0.8 you will get. 0.8. What is the answer? 0.826, approximately equal. Because we are ignoring some higher values. That's why correct to one decimal place only, you will get correct values. No problem. So you get the same answer. Suppose you know V means you replace I by I equal to what? V into I equal to, by Ohm's law, I equal to V by R. That is equal to V square divided by R. V also we know 0.92. Therefore, 0.92 whole square divided by R 1 ohm. How much? 0.8. 0.8. 846. Okay, 846. So because we are truncating the higher decimal places, that's why you are getting like this. Okay, but anyhow, 0.8 you will get correct value. If you write some 4 or 5 decimal places, you will get correct value, all equal values. Okay. But so power equal to what? Vi or I square R or V square divided by R. I square R or V square divided by R. All the three can be used. It depends upon what value is available. What value is available.